Hello students, welcome to one more session of your WOC, that's your one man, just presenting in front of you as promised, the new pattern question paper, that is your multiple choice questions. So basically students, there was one video where I have told you that I'll be presenting everything for you all. So just let us see how to solve and how to just get marks in the exam. So let us start off with the first question, and I request you all to please share it, because for any person or for any educator it takes a lot of time for us to design, frame and present it in front of you. So this is my idea of helping you out so that you'll get that complete 35 marks objective type in your board examinations. Thank you for being a constant support for WOC. And here again I'll be presenting a series as and when I get time. I think you all know I'm also sending the links of the free sessions which I'm conducting for you all in an academy, like the organic reasoning series, so which is pasted in the community tab. So please watch that. So with your support, with your guidance, let us start off with the session today. Let us see in the MCQ series, the first question will be read, question will be solved, and you will get an analysis of how to do it. Thank you so much, students. Let us read the question first. So here in the first question, if I have to read, among the following, let me take a pen once, right? So pen is here, right? So among the following, which reagent cannot be used to prepare an alkyl chloride from an alcohol? So here, as we know, we have MCQ questions, basically almost as we said in the new upcoming pattern 2020 and 21. You have almost 35 marks MCQs, assertion reasoning questions. I've also sent a video which explains about the new pattern paper. Please watch it. So according to this question, let us once again go through and read it carefully. As I said, right. So among the following, which reagent cannot be used to prepare alkyl chloride from an alcohol? Okay, done.
T20 Bonanza series on isomerism, IUPAC and hydrocarbons by Mohammad Kashif Alam. This is a very famous and result-oriented course which is available for IIT JEE Mains and Advanced on Unacademy Plus. Students, basically this was a special session which was conducted from 1st October to 30th October. So in this particular course, it was, conducted in different sessions. Day 1, as you're seeing, as a special bonanza in isomerism, IUPAC and hydrocarbon. It was also conducted on the day 2. It is conducted again on the day 3, day 4 and day 5. As you've seen, each and one session is explained very clearly in a detailed way on day 6, day 7, day 8, and it continued till day 9, and it also went on further till your day almost 15 to 16 and even the 17 days. It is a complete course. As you have seen, almost 20 days a complete package was taught. The topics which were selected by was isomerism, IUPAC and hydrocarbons. So this is a recorded session. Now when you go through the link which is pasted in the description, you will get a clear explanation. It's free of cost, students. You can watch all the videos which are kept and which gives you a clear understanding about the topic. So Unacademy has provided this facility for you all to go through the links and get a clear understanding of all the concepts. Thank you so much, students. So please watch. The link is pasted in the description.
So basically this is a preparation of an alkyl chloride. Alkyl chloride comes to be this one. I have to use alcohol for this. So what happens when I see among everything, see in the exam paper when you see chloride, don't assume that I can easily replace OH with this chlorine and prepare it. No, students, you should be very careful. Here this is a molecule, this is a Lucas reagent, this again is a molecule. When I compare all these, sodium chloride is the only element which is, only compound which is ionic in nature, isn't it? This is ionic in nature. Because of this, I can't use NaCl for conversion of alcohols to alkyl halides. So normally what happens when I take SOCl2 or when I take HCl and ZnCl2 or PCl5, here OH is replaced by the Cl minus ion, correct? No? OH is replaced by the Cl minus and we get the alkyl halide. So the odd one out is option A, that is nothing but NaCl. Why? because it is ionic in nature. Remaining all, when I see this, it gives SO2 sulfur dioxide gas, correct? HCl as a byproduct. Lucas reagent is going to replace the OH minus in convert it into RCl, isn't it? Like PCl5, if I have to see, it's going to replace the OH minus ion and forms POCl3 and HCl. Isn't it, students? Right. So the option which is odd one out is sodium chloride. Now, let us see the next one. They have given me one particular compound here. This is nothing but your secondary alcohol. So when it reacts with KBr and concentrated sulfuric acid. So here what happens? This is a nucleophile, right? Now in this particular reaction which is given, you have bromine which is acting as a nucleophile. So this nucleophile is replaced by the bromine atom which is there, and you are going to get a compound that's nothing but your CH3 is here. Your bromine is attached to the carbon where OH is replaced and CH3. Right? So what is the compound here? You're getting the compound that's nothing but 2-bromopropane. Now, ma'am, how will I know which is the nucleophile? Normally when I see when bromine reacts with concentrated sulfuric acid, the product or the reaction goes like this. So what is the reaction? It's going to react now. If I take this whole compound, sulfuric acid, I can write it as H plus and HSO4 minus, isn't it? So, right? So same thing. The potassium, this plus and minus, this is going to react with this HSO4 bisulfate and forms KHSO4. Okay, KHSO4. Now suppose if I am taking 2 moles of this, right? So bromine comes out as Br2 and the sulfate will comes out as sulfur dioxide and your water. So here as you have seen, bromine is released. In the same way, bromine would be the nucleophile which goes and attacks the OH. It's going to replace the OH minus. So the correct option is B, which will be marking as B. That's fine, students. Perfect. Now let us see the next question. When it comes to question number 3, 1,2-dibromomethane can be prepared by treating with which one? I have to prepare 1,2-dibromoethane. So what will I do? I'll write the compound like this. 1,2-dibromoethane. Ethane means how many carbons? 2 carbons, isn't it? So this is your CH2, CH2, and in the first position and in the last position you have bromines. So 1,2-dibromoethane. I have to prepare this. That means in the parent atom also I need 2 carbon atoms only. Correct? No? So here ethylene is given. Propylene I can't take because I need only 2 carbon atoms. So this is ruled out. Then here 1,2-difluoro is given. I don't require fluoro. This is also ruled out. Now next thing are ethylene with bromine, ethylene with less amount of HBr. Just check, students, when both the carbon atoms have to be replaced, I can't take less amount of HBr, isn't it? So this is also ruled out. So the leftover option is A. So let us write the reaction now. You have ethylene, CH2 double bond CH2, you have Br2. And here when I take one more pen, let me take one more color, that's your blue. That's, yeah, this bond is broken from here and bromine is added at both the sides. So finally what do you get? You are going to get 1,2-dibromo, this one ethane in the presence of ethylene with bromine. Simple, isn't it? Now let us see this. The characteristic reaction of alkyl halide among the following reaction. So characteristic reaction of alkyl halide. So when I talk about alkyl halides, it is nothing but, I think I have to change the pen to black, students. Okay. When I take alkyl halide, that is your RX. So when I talk about RX, basically nothing. X can be, it can be chlorine, it can be bromine, it can be iodine. What is the speciality of these? These are all good leaving groups, correct? No? These are all good leaving groups. When these are good leaving groups, what is the concept? They can easily undergo substitution reactions. Accepted. Now important thing, these are all nucleophiles, correct? No, these are all negative charge. So when there are good leaving groups and nucleophiles, what would be the option? And they will undergo option C, that's nothing but nucleophilic substitution reactions. So here the answer would be nucleophilic substitution reactions C. Simple, isn't it? Now let us see one more question. Question number 5. Here they have given me a particular compound and this is one more sodium ethoxide. Don't get panic seeing the reaction. Simple. whenever alkyl halide is given, first you count the number of carbon atoms, 1, 2 and 3. Then you have sodium ethoxide here. So what is the speciality? It's going to break up. It's going to, let me take the red pen. It's going to break up exactly as sodium ethoxide negative, Na plus positive. Here also this is a good leaving group I said, isn't it? So what is going to happen? A minus Na would come out. Na would come out. The leftover you're going to join. That's all. The leftover compound you're going to join. So what are you going to get? 3 carbons here and 2 carbons here. Nothing but CH3, CH2, CH2, O, CH3, CH2. Okay, CH2, CH3. So if you are writing in the other way, suppose if you are writing in the other way, CH2, CH3, and you are writing the propyl group, that's right. No problem. So that would be the major product. So here, what is the answer if I have to take? If you are writing in this way, suppose let us assume because the option here, you don't have here 1 carbon, 2 carbon, 3 carbons, 4 carbons. This option is wrong. Next is 1, 2, 3. This also is wrong. This option also wrong. But what is important here? The compound which is there, that is your ethyl and the propyl, because when you break it forms into 2 different compounds, isn't it? So what do we do? Let me take that. What do? We are going to write it as the other way. Let us take this because the option which is left is only this, isn't it? And that is a major product also. So CH3, CH2O, CH2, CH2, CH3. This is the compound. Perfect. So the answer here is B. Done. Let us come to the 6th question. The product formed when 1-bromobutane reacts with alcoholic KOH. Yes. When alcoholic KOH concept is given, remember, important thing, you should know the role of this. Correct, students? What is that role? What is that role? Important thing. Check carefully. Let me take a black pen. Alcoholic KOH role is nothing but it's going to undergo dehydrohalogenation. This is the main role. Dehydrohalogenation is the main role. Correct? No? Yes. Dehydrohalogenation means you're going to remove an hydrogen and a halogen. Now, they said 1-bromobutane reacts with alcoholic KOH. Take that compound 1, 2, 3, 4 and 1-bromo. Alcoholic KOH, you're adding AlCKOH. Now what we will do? It's going to remove 1 hydrogen and 1 halogen from the group. Where it's going to remove? If I have to take one more pen, it's going to remove bromine from here and hydrogen from here. Correct, no students? It's going to remove bromine from here and hydrogen from here, and it's going to basically means the hydrogen which is here, the bond is going to drop in this case. Then what will I get? I'll be getting a compound something like this. What is the compound? I'm going to get a compound CH3, CH2, CH2, correct? Double bond CH2. That means wherever you're taking out bromine and wherever you're taking out hydrogen, the double bond formed, you'll be getting 1-butene. Yes or no, students? 1-butene. Carefully, no, once again, let us see. If you're taking out from the first one, okay, suppose if you're taking out from the first one, let us check. Right, here you're only taking, because what happens, bromine is lost, and this is where you have taken out, and this becomes 2-butene, isn't it? Correct, students? Because bromine you have taken from the first carbon, double bond has formed in the second carbon, so the option is, here you'll be writing as 2-butene, right? Now check. In the seventh case, right, students? Now once again, let us once cross check. And write the reaction. Let me take the eraser part. Okay, sorry, eraser. If I have to say, sorry. Okay, fine. Right, students. I think little confusion with the eraser. Yes, I took the eraser. Let me erase it once again. Write it for you all. Right, I'm sorry. Okay, let us see once again the question. Here, the question is little bit 1-bromobutane. I took it from the other side. You can write in that way. Suppose if you write this particular option in this part, okay, how? In this way, just check. Same thing I'm writing. 1-bromobutane, I'm writing in this CH2Br. Okay, this is okay. CH2, CH2, CH3. This is okay, students? Right, not to confuse you all. So here what happens, I am taking alcoholic KOH. What should happen? Dehydrohalogenation minus HBr. From where will I take out? I'll take out bromine from here. I'll take out hydrogen from here. Same compound which I am writing. So it becomes CH2 double bond CH2 CH2 CH3. Perfect. Right. Now, when I take the seventh question, here they've given me 2 bromobutane. 1, 2, 3, 4. Bromine here is on the second carbon. Then again I'm taking alcoholic KOH. What should I do? I have to just do dehydrohalogenation HBr. From where will I take out? I'll take out 1 bromine from here. Perfect. Then I'll be I'll be taking 1 bromine from here and 1 hydrogen from here, because if it is CH2, 1 hydrogen from here. What compound will I get? I'll be getting it as, this is one only, I'll be getting the compound as CH3 CH double bond CH CH3. Correct, no students? So this is 1 butene in this case. If I take here, in this case, if I take, it is 2 butene. So the option here is B. Here it is 1 butene. Here it is 2 butene. Perfect. Now, students, now let us come and see the 8th question. Again, here also they have given us alcoholic KOH. So what should you remember always? Whenever alcoholic KOH is given to you, the concept is it undergoes dehydrohalogenation. That is what is the concept. So wherever you have, just take out the hydrogen and halogen adjacent to that. Now, let us check this. Here, what do you have? Isopropyl bromide. Now, isopropyl bromide, let us write the structure. So, if I say isopropyl bromide, now, simple thing, students. So, here, just second carbon, correct? Second carbon you're taking. So, in the center, you have bromine. This is your isopropyl group. Again, you're going to take alcoholic KOH. What should you do? You have to take out HBr. From where will you take out? Br from here and hydrogen from here. No problem. Br from here, hydrogen from here. Right? Suppose if I take hydrogen from here, what will I do? I'll take out 1 hydrogen from here. So what is going to happen? That hydrogen bond is going to drop on this carbon and you're going to get CH3 CH, because bromine has gone double bond CH2. Correct? Yes. So in the what compound is this? This is nothing but propene. So the answer here is A. Simple, isn't it? Concept is what you need to remember, and you need to write the reaction and just think before answering it. Let us see question number 9. Till now I was learning about alcoholic KOH, dehydrohalogenation. Now let us study about aqueous KOH. What is the specialty of aqueous KOH? Whenever you see in the paper aqueous KOH, you need to remember it undergoes or helps in hydrolysis. You are going to do the hydrolysis process with aqueous KOH. Correct, no students? Alcoholic KOH is dehydrohalogenation. Aqueous KOH is hydrolysis process. Now, what compound did they give? They have given 2,2-dichloropropane. Now, let us write the structure. 2,2-dichloropropane. When I take now propane, I'm sorry, students. Let us go back. 2,2-dichloropropane. Let me write in this way. Why? I think my pen has disappeared somewhere. 2,2-dichloropropane. Now see here, 1, 2, 3. Okay, 3 carbons. So dichloro. So in the second carbon and second carbon to the same carbon atom, 2 chlorine atoms. So this is 2,2-dichloro. Now we are going to take aqueous KOH. What should I do? I have to do hydrolysis, because it helps in hydrolysis. Alcoholic will help in dehydrohalogenation and aqueous will help in hydrolysis. So hydrolysis means nothing. You're going to replace this OH chlorine with your OH minus. So your OH is going to replace this chlorine and it's going to replace this chlorine also. Finally, I'm going to get OH and OH. Perfect. Right? So both the compounds are done. So what is this called? Again, 2,2, because in the same carbon, this is 1 and this is 2. So the second carbon, you have 2 OH groups. Correct, no students? Second carbon, 2 OH groups. So the name of this compound is nothing but 2,2 propane diol, or you can also write it as propane propane 2,2 diol. Simple. Yes, students. Hope it's clear. So wherever it is there, simply replace with OH. So the correct option is A. A is the correct option. Now, let us see the question number 10. I think you're all understanding how to do. Right. Now, again, this is aqueous KOH. What should I do? Hydrolysis. That means what? Your OH minus is going to replace the chlorine, whatever halogen is there. Now, here it is 1,1-dichloropropane. Right, students? 1,1-dichloropropane. So basically 1,1-dichloropropane, CH3, hydrogen in the first one, chlorine. Correct, my students? Now 1,1-dichloropropane they said. Now here basically how many carbons are there? 2 carbons. So shall I make this as CH3 and this is CH2? Okay. Now I'm going to add aqueous KOH to this. So what should happen? One chlorine from here, one chlorine from here gets replaced. Correct, no? One chlorine from here, one chlorine from here gets replaced. So what is going to happen? CH3, now CH, this H is here. Let us write H here. This OH is here. Right. So here basically what happens, let us take this as CH2. Let us take this as CH3. Now this is a very unstable compound. Very unstable compound. So what is going to happen further? Water is lost from this. Water is lost from this. So here what happens when water is lost, H2O is lost. What is left out? What is left out, students? You are going to get CH3, CH2, CHO. Correct, no? You'll get a propanaldehyde compound. Because hydrogen is lost, you will get CH3. So water is lost, CH2, CHO. Correct? What is this compound? Propanaldehyde. But here, is there any propanaldehyde option? Propanaldehyde option? No. Why? Now just check here. Careful. Propan or the correct answer basically here is acetaldehyde. Okay. The correct answer is acetaldehyde. Why? Because when they said 1,1 dichloropropane, okay, so here what did we do? 1, 2, 3 options we get. 1, 2, 3. So this is 1,1 dichloropropane. Perfectly taken. But here no option is given to us. So what should you do in that cases? You can write this reaction here and leave it, and you can write the compound here as propanaldehyde. Okay, that's fine. Right, now check students, 11th question. Which compound listed below will not give a white precipitate with alcoholic KOH? Now when we say alcoholic silver nitrate, when we say alcoholic silver nitrate, what does it do? What is its role? It helps in, or it will undergo elimination reaction. Elimination reaction. So recently I said no, when it is alcoholic KOH, dehydrohalogenation. Aqueous KOH, I said hydrolysis. Now alcoholic silver nitrate will undergo elimination reaction. Now when I take elimination reaction, so they said which will not give a white precipitate. So normally what happens when I take the reaction, let me take any other, okay. Now I'm taking 1 bromopropane, CH2 CHBr. Now when I take this reaction with your AgNO3, okay, AgNO3. So what happens? It has to lose the halogen, it has to lose the hydrogen, and it will form basically elimination product. So alcoholic silver nitrate, it's going to form 1 bromine here, 1 hydrogen there, and you're going to get CH3, CH, double bond CH2, because you're taking out bromine here, hydrogen here, and KBr and water. Correct, no? Right? Now, what is happening here? Comfortably, bromine, there is nothing like delocalization or resonance, nothing. Perfectly, it can replace and give you the required alkene, because elimination reactions give alkenes, isn't it? That's fine. But which will not give the set? So when you check all these options, there is only one compound with a benzene ring. So when you see benzene ring, what actually is, what will happen? Just tell me. In benzene ring, you have the concept of resonance. You have the concept of delocalization. So in this particular case, when the benzene or the bromo group is attached to the benzene ring, all the electrons or the bromine, whatever is there, it gets delocalized towards the benzene ring from here. So where will the bromine react with alcoholic silver nitrate? It can't react because it is in conjugation with the benzene ring. So it's not going to react with the alcoholic KOH, and so the odd one out is bromobenzene. Bromobenzene will not react with alcoholic silver nitrate because of the conjugate systems. It's going to form a conjugation with your ring. Okay, that's fine. Now let us see the next question, question number 12. So here carbylamine reaction, the carbylamine test involves heating a mixture of, careful, simple students, carbylamine reaction are basically shown by primary amines, correct? No, this is the rule which we know, right? And during this process there is a intermediate which is formed, that is called dichlorocarbene, correct? No, right? So here when primary amine, if I have to see the reaction, let me take one reaction and I'll show you. CH3 CH2 NH2. So what do I require? Compulsory I require chloroform, because I have to form a intermediate dichlorocarbene intermediate, isn't it? So for that chloroform, and you're going to take KOH. Alcoholic KOH, remember that. So when they all join together, that is, you're taking 3 moles of KOH, potassium hydroxide, and in the presence of chloroform, this hydrogen is replaced and it forms isocyanide compound NC. Perfect. And 3 KCl as usual, and 3 water molecules is also there. So the most important requirement here, if I have to change the pen and C, requirement is chloroform to form this dichlorocarbene intermediate, alcoholic KOH also, and then final thing is primary amines. So the option C is correct, isn't it? Option C is correct, which has all the 3. Done. Question number 13. Which of the following compounds will not give white precipitate with alcoholic KOH, alcoholic silver nitrate? Same thing. Alcoholic silver nitrate, if you see, immediately you need to say that it is an elimination reaction. Let me take a pen. Okay. It undergoes elimination reaction. Now, elimination reaction. Now, important. I said for something to undergo, see in this reaction, something to undergo elimination, the particular bromine should be free enough to be substituted. Correct? But what did we say here? Bromobenzene, it is in conjugation with the benzene ring. Same is the case here. See, where is benzene? Chlorobenzene. So this is the option, no? Here in chlorobenzene, what happened? Here the compound chlorobenzene, it is in conjugation with the ring system. Correct, no? So it is not available, or there is no free availability of chloride ion. Correct? So when a silver nitrate alcoholic is added to this, there is no reaction. So plus alcoholic AgNO3, there is no reaction. Why it is no reaction? Why there is no reaction? Because it is conjugated with benzene ring. Correct? No? This is the thing. Right. Now, very nice. So the option is C here. Now let us see almost last 2 questions, students. Now see. Identify the end product C in the following sequence. This such type of questions are frequently given. Check carefully. So in the end product of the following sequence, ethanol is given to me. Whenever you see thionyl chloride, always remember the products are sulfur dioxide gas, HCl gas, and your OH is replaced by the Cl. Okay. One chlorine comes out as HCl, one chlorine comes out as this. So what is the compound A? If I have to write C2H5OH plus SOCl2 in the presence of pyridine, a stronger base than that. So what you get? C2H5Cl. This is compound A. Now further you're treating with KCN, alcoholic. So what is going to happen? Let me take this pen. What is going to happen? The chloride from here is replaced by the cyanide, the nucleophile. So what product do you get? You're going to get C2H5Cn. Now cyano groups, when you undergo or when it undergoes hydrolysis, always remember irrespective of the size of the carbon chain, they're going to get converted into acids. Correct? No? Whenever you say cyano, irrespective of the carbon chain, they're going to get converted into acids. So what is the correct option? Correct option is C. Perfect. This is A. This is your B. This is your C. Last question. Bromination of methane in the presence of sunlight is what? So whenever you see sunlight, simple. In the presence of sunlight or HNu, free radicals are formed. Correct? No? Sunlight means free radical because the reaction becomes faster. So free radicals are formed, and that's why it is called free radical substitution reactions. So as you all know, bromination, methane, 1,1,1,1 atom keeps getting shifted. 1,1 bromine atom, 1,1 bromine atom keeps getting shifted, and finally you get the product. So that is how 1 HBr gone. So bromine Br2 breaks as bromine free radical and forms your compound, that is CH3Br. Right? So free radical substitution reaction is answer. So this is my MCQ series, students. So please share it. I hope all the explanation is clear. Every question I have given the reason. I've explained you clearly. Please try to share it with your friends. I'll be coming up with one more series very soon. Thank you so much. Please share and please ask your friends to subscribe. Make it a series a success. If you are making it successful, I would love to do the series too.